Hi everyone, we are going to learn about the sixth experiment, that is, design Verilog programs to implement different types of multiplexer like 2:1, 4:1 and 8:1. Multiplexer, it is a combinational circuit that selects binary information from one of many input lines and directs it to output line. Sometimes you will find multiplexer written as mux, and advantages are reduces the number of wires and reduces circuit complexity and cost, and also implementation of various circuit using mux. There are different types of multiplexer: 2:1 multiplexer, 4:1 and 8:1 multiplexer. This output is always 1 in 2:1 multiplexer. The multiplexer itself is made up of different logic gates. How you can implement different logic gates using the 2 to 1 multiplexer, and first let us start with the NOT gate. So for this 2 into 1 multiplexer we have two data lines and one selection line, and the input to the selection line decides which input appears at the output. So this is the Boolean expression of this 2 into 1 multiplexer in terms of the selection line and the data line. Now in case of NOT gate, if the applied output y is equal to a bar d0 plus a d1, input is a, then the output is equal to a bar. So to use this multiplexer as the NOT gate, first of all let us apply this input A to this selection line and now let us apply this 1 to D0 line, and 0 to this D1 line. So as per this expression, this output y is equal to a bar dot 1 plus a dot 0. The output y is equal to a bar. So in this way we can implement the NOT gate using this 2:1 multiplexer. From the truth table, let us see what should be the input to the data lines. So when this A is 0, then the output y is equal to D0. When this A is 1, then output y is equal to D1. This is the output y is equal to a bar D0 plus a D1. This is the truth table for 2 to 1 multiplexer. This is the Verilog code for 2:1 multiplexer, and in this program module is a keyword, and the input variables are D0, D1, A, and the output variables is Y. Register output Y. The function always at represent all the input variables D0, D1, A, and operator has begin has based on selection line. In selection input lines connect to output, and finally close it end module. This is the output of this program. then 4:1 multiplexer. Similarly, 4 to 1 multiplexer, there are 4 input and 1 output, and to select any one of the 4 input there are 2 selection line. So depending on the input to the selection line, any one of the input connected to the output, and this is the truth table of the 4 to 1 multiplexer. So as you can see, when both A and B are 0, then D0 get connected to output. Likewise, when the both A and B are 1, then these D3 input get connected to output, and from the truth table we can easily write the algebraic expression of the multiplexer. The output y is equal to a bar b bar d0 plus a bar b d1 plus a b bar d2 plus a b d3. This is program for 4:1 multiplexer. The input variables are D0, D1, D2, D3, A0, A1, and output variable is Y, and register Y output. The function always add represent all the input variables and operator begin, and finally close the end module. This is the output of this program 4:1 multiplexer. Then 8:1 multiplexer. Like, we can also design 8:1 multiplexer. So in 8 to 1 multiplexer we have 8 inputs and 1 output, and to select any one of the 8 input there are total 3 selection line, and this is the truth table of the 8 to 1 multiplexer. So as you can see, this is the truth table of 8:1 multiplexer. As number of input to the multiplexer increases, then we also require AND gate and OR gates with more input. From the truth table of the 8 to 1 multiplexer, when the selection input is 1 0 0, then this D4 input should get connected to output. So in this case also, when the selection input is 0 0 0, then this D0 input should get connected to output. So let's see that how the same things happens here. And from the truth table we can easily write the algebraic expression of the 8:1 multiplexer, and output y is equal to a bar b bar d0 plus a bar b bar c plus a bar b c bar plus a bar b c plus a b bar c bar plus a b bar c plus a b c bar plus a b c. This is the expression of 8:1 multiplexer, and this is the Verilog program code for 8:1 multiplexer. The input variables are D0, D1, D2, D3, D4, D5, D6, D7, A0, A1, A2, and the output is Y. And register output y. Function always add, represent all the input variables, and operators begin, and finally end with close with end module. This is output of this 8:1 multiplexer. Thank you.